go straight to our answer of 9. Now, let's look at trigonometric ratios now. Label each right angle triangle below with the missing information from the following. We have hypotenuse, we have opposite, adjacent, and so forth. So, in case it's a little new to you, you should have remembered in the first part or the first lesson how to identify the hypotenuse. So you identify the right angle, and opposite the right angle is your hypotenuse. So we can identify the hypotenuse in all of these. Here's my hypotenuse. Here's my hypotenuse. Here's my hypotenuse. Here's my hypotenuse. And here is my hypotenuse. Okay, now let's identify two new things, the opposite and adjacent. Now, these are not based on the right angle. The opposite and adjacent are based on the acute angle. So we identify the acute angle here. Here is the acute angle. We want to identify that angle, and the side that is opposite the acute angle, the side that is opposite the acute angle is what we call, yes, the opposite. So opposite the acute angle, that's the angle that's less than 90 degrees. And that's the one shown here. Remember, if this angle is 90 degrees, it means that the other two angles will be acute angles, because together they have a sum of 90, because 90 plus this 90 here is 180. Remember, the sum of angles in a triangle is 180 degrees. So this angle, and this angle added together will give us 180, which is the sum of angles in any triangle. And since in a right angle triangle we already know that this is 90, then the other two must add up to 90 to give us 180, which makes these two less than 90 each, since they must add to give us 90. And so therefore, being less than 90, they are called acute angles. Now this is the acute angle that we identify as theta here. And so therefore, this is what we're talking about. So this side here is our opposite angle theta. Now theta is a Greek letter which simply means an angle, an unknown angle. Okay, so let's identify all our opposites. So opposite this angle here is my opposite side. Opposite this angle, the acute angle here, is my opposite side here. So this is my opposite side. Opposite, well, we don't have an acute angle here, but this is recognized to be, let's look at it. This is recognized to be our what? This is recognized to be our opposite side, which means that this opposite side here is facing this angle here. So this angle must be theta. And based on what we're looking at here, it says fill in with the missing information, and we also want to fill it in with the what? The acute angle theta. So now that you understand a little better, this is our what? Our opposite side. So where is the theta, the acute angle? Must be here. So here will be our acute angle, which is facing this side, opposite this side here, call it opposite, which stands for O here. The opposite stands for O. And again, opposite the acute angle is the side that will mark O, or OPP for opposite. All right. Now, in a right angle triangle with an acute angle, the right angle tells us where the hypotenuse is, and the acute angle will tell us where the opposite side is, as well as where the adjacent side is. So, the adjacent side is that side that is next to the acute angle. So just as this side here is opposite the acute angle, then this side here is next to it. And the word next to also can be translated as adjacent. So this is our adjacent side, which is the side next to, because adjacent means next to, which is the side that is next to the acute angle. Another way of identifying the adjacent side is the side that contains the 90 degrees angle, or the side that is helped to be formed by the 90 degrees angle, as well as we can say it is formed with the acute angle as well. So it's a side that has both right and acute angle. All right, so if we look at this side here, this will be our adjacent side, since we already identified the opposite and the hypotenuse. So this must be the adjacent side. But again, even if we didn't identify the hypotenuse, it's a side that's next to the acute angle here, theta. Also, we can say that this side here has both the acute angle and the right angle. This side down here has both the acute angle and the right angle. This side here, adjacent, has both the acute angle and the right angle. And we identify this as the theta that faces the opposite side. So this side has both the acute angle and the right angle. So this is our adjacent side. And of course, which side will be our adjacent? Can't be this, because this is already our opposite theta. This is our opposite side. This is our hypotenuse opposite the right angle. So this must be our adjacent side, which has both the right angle and the acute angle. Glad you've mastered that. Well, let's see. If this is my adjacent side, it means that theta will be right here, because the adjacent side has both the right angle and the acute angle. And if this is the acute angle theta, then this side facing it will be my opposite side. And this side, of course, will be my hypotenuse, the side that faces the right angle. Now here we have the acute angle that's less than 90 degrees, so this side here is my opposite. This side facing the right angle is the hypotenuse, and this side is the adjacent that has both the acute angle and the right angle. Or we can say it's next to the acute angle. This is acute angle, which is less than 90, so this is my opposite. Opposite the right angle is the hypotenuse, which is there already. And this must be my adjacent side remaining. But again, it has the right angle, acute angle. This is my opposite, so facing the opposite is my acute angle. This is right angle here, facing it is the hypotenuse. And this side here will be the adjacent, because it's next to the acute angle. But it also is helped to be formed by the right angle. So it has both the right angle and acute angle. This is my opposite side, which means that it faces this angle, which is the theta, the acute angle, the angle less than 90 degrees. Which means this is my adjacent, which has both the right angle and acute angle. And opposite right angle is my hypotenuse. What about this one? Can you identify the opposite? That's right, this will be my opposite. This will be my hypotenuse opposite the right angle. This will be my adjacent. It's next to the acute angle, but it also was formed by the right angle. The next stage, we have these three trig ratios that you want to bear in mind. SOH CAH TOA. We have sine theta equals opposite over hypotenuse. We have cosine theta. When I say theta here, we can be of any acute angle, any angle less than 90 degrees. Cosine of angle A is adjacent over hypotenuse. And tangent of the acute angle is opposite over adjacent. Now notice that we have SOH. So we say that's so, as you can see here. And we have CAH. So we say CAH. Then we have TOA. And so we say TOA. SOH CAH TOA. If you can remember this, then it'd be helpful. But the formula sheet will be given on your exam anyway. But the idea is to understand what these all represent. And all this is saying is that if you divide the opposite side of the right angle triangle by the hypotenuse, you will get the same answer as when you press sine of the angle, the acute angle that would have identified the opposite and adjacent side. Let's see further. So remember, sine opposite of hypotenuse can be treated as a SOH. Cosine equals adjacent over hypotenuse, CAH. And tangent of the acute angle, opposite of adjacent, TOA. Now, as you can see, here we have angle A, and why this side is opposite? Because, as we can see, this side here faces angle A, and this side is next to angle A, so it's adjacent to angle A. And this side faces the 90-degree angles, right? The 90-degree angle. So this is the hypotenuse. Use the triangle below to find the sine of 36.9 degrees, cosine of same angle, tangent of that same angle. So we're given the three angles. Well, we're given the three sides, and we have the acute angle 36.9 degrees. So opposite of this 36.9 degrees is the side we would call opposite. And next to the 36.9 degrees is this side we call the adjacent, which has both the acute angle and the 90 degrees angle on it. And last, we have what? This side, which faces the right angle. So this is our hypotenuse, which is 10 centimeters long. All right, so we got these sides. Now, as we can clearly see that we have the opposite. As we can clearly see that we have the opposite, we have the hypotenuse, and so the sine of 36.9 degrees is equal to the opposite side, which is this side here. Remember, sine is opposite over hypotenuse. SOH CAH TOA, SOH. So that means the opposite 6 centimeters over the hypotenuse 10 centimeters. And so what that gives us, when we cancel out the centimeters, that's 6 centimeters over 10 centimeters, we end up with 3 over 5. That is 2 into 6, 3 times, and 2 into 10, 5 times. By the way, a calculator could do this. But nevertheless, if we divide 5 into 3, we get 0, put a point. And we put a 0 next to the 3, that's 30, so 5 and 30 goes 6 times. So the sine of 36.9 degrees is 0.6 approximately. So if you do that with your calculator, you realize that will be correct to 1 decimal place there, right? And let's look at the cosine of 36.9 degrees. The cosine, that ratio is the adjacent over hypotenuse, CAH, C-A-H. All right, adjacent over hypotenuse. Now remember, you get this formula in the exam, so you don't have to worry about it. Now the adjacent, again, is the side that has both what? That has both the acute angle and the right angle on it. And so cosine is adjacent, which is 8 centimeters, over the hypotenuse, that side that faces the 90 of 10. And when you cancel the centimeters, you get 4/5, because 2 goes into 8 4 times, 2 into 10 5 times, and 5 into 4 gets 0.8. Calculator can do that. So that means the cosine of 36.9 degrees is 0.8. And let's look at the tangent now. The tangent of 36.9 degrees. Remember that what tangent is. Tangent is opposite over adjacent, TOA. Now the opposite, meaning opposite the acute angle of 36.9 degrees, we have the side 6 centimeters. So we know the opposite is 6 centimeters and the adjacent is 8 centimeters. So that's 6 over 8. And then when we cancel that 2 into 6 goes 3, 2 into 4, 2 into 8 goes 4 times, and 3/4 is 75 cents. In this case, 0.75, since we're not dealing with money. Now, let's look at it. Let's assume that we wanted to find, let's say we didn't have the 6 centimeters. Let's say we made it unknown. Then let's see what we'd have here. We will put x over 10. Instead of saying 6 over 8, I should say, opposite over adjacent. That will be x over 8. And then we want to find x. So we simply multiply tan 36.9 degrees times 8. But it's a different method. This method is simply getting rid of the denominator by multiplying by 8 itself. So what will happen here is that this will cancel out this. And since we multiply this side by 8 centimeters, we also multiply this side, which is tan 36.9 degrees, by 8 as well. So this gives us x equal 8 multiplied by tan 36.9. So in your calculator, you simply put 8. You don't have to put, well, you wouldn't put centimeters in your calculator. You simply put 8 tan 36.9. So let me go over this again. So I'm saying you wouldn't put centimeters in your calculator, obviously not, but you'll put 8 tan 36.9, and that will give you what? That will give us 6.0064, yada yada. So what we need to do is correct this to one decimal place. Let's assume that they asked us to correct it to one decimal place. Our two significant figures, we go 6.0. We check the very next digit, which is a 0. And since the very next digit is, one moment, since the very next digit is a 0, we maintain the 0 here as 0. So 6.0 centimeters correct to one decimal place. Or we can call this two significant figures as well. All right. So let's assume that, this same angle. So let's go back here. We see we have 36.9 degrees here, right? Let's assume that we make this theta. Let's say we make this angle here unknown. Let's call it theta, the Greek letter theta. Then this is what happens. Yeah, we can still calculate that angle, which is 36.9 degrees. How do we do that? Well, we could use any one of the trig ratios. So let's assume that we use tangent of theta, tan of theta. Since we have all the sides, it's easy for us to use any of the trig ratios. We could use cosine theta, sine theta, but we're using tan theta. Now, tangent of theta, or tangent of the acute angle, is equal to the opposite side over the adjacent side. So all we need to do is get the measurement for the opposite side, which is 6 centimeters, over the adjacent side, which is 8 centimeters. And then we need to transpose this tangent over. Now, once we move tan from the left to the right or right to the left, it changes to the inverse tan. So all we're doing is going to write back the theta. This tangent will no longer be there because we transpose it on the other side. But when it goes to the other side, it changes to the inverse tangent. And then inverse tangent of what? Inverse tangent of what is already there, 6 over 8. Now, centimeters cancel centimeters, so we know we're not going to have our answer in centimeters. And the inverse tangent of 0.75 will give us our answer in degrees. So we keep putting back theta since we're not doing anything to it, but it will be read as theta equal 36.9 degrees. That is understood. As I was saying, we could have used cosine, so we could have said cosine theta equal. Now cosine is equal to what? Remember, it's SOH CAH TOA. Right? We could have used cosine. Why? Because we have the adjacent and the hypotenuse. So cosine theta equal adjacent, which is 8 centimeters. Remember, this is adjacent over hypotenuse, so it's 8 centimeters over the hypotenuse of 10 centimeters. So that what we have here. Centimeters cancel centimeters, and this will be cosine theta of 8 over 10. And then we want now to find the inverse, right, of inverse cosine of 8 over 10. Also, because we want to find what theta is, so we're going to transpose the cosine over, and that is now cosine inverse of 8 over 10. So we want to find what the inverse cosine of 8 over 10 is. And of course, that would also be 36. Check with a calculator. That would be 36.9 degrees, thereabout. And the same thing we should use sine. Sine theta of what? Sine theta of, remember sine is actually opposite over hypotenuse. So we get the opposite length. Let's get some space here. So sine theta is equal to the opposite over the hypotenuse, correct? So sine theta is equal to, what's the opposite? The opposite is 6 centimeters, as we have right here, over the hypotenuse, which is 10 centimeters. Centimeters cancel centimeters. And so this is now going to be transposing the sine over. We have theta isolated now equals sine inverse. Since we transpose sine to the other side of the equal sign, that becomes sine inverse of, no, 6 over 10 is 0.6. Or you can leave it as 6 over 10 in a calculator, doesn't matter. And so the sine inverse of 0.6 or 6 over 10 will be approximately 36.9 degrees as well. So no matter which one of these trig ratios we use, as long as we have the two sides we need to calculate that particular value of theta, then we know the answer is going to be the same thing, 36.9 in this case. All right, so here we have the progress question. The diagram below shows a quadrilateral, meaning a four-sided shape, PQRS, P, Q, R, and S. So those are the four vertices, and of course it means that we have four sides. If you look at it, we have PQ, QR, and RS, and SP. So that's 1, 2, 3, 4. All right, now it says PQ and SR are parallel. So let's check it out. PQ and SR are parallel. So it means that this side here is parallel to this side here. These arrows mean parallel. Okay, and SQ is 8 centimeters. So going from S to Q, we have a distance of 8 centimeters. So S to Q has a length. In other words, this side here is 8 centimeters. We are also told that the angle SPQ is 90 degrees. SPQ is 90 degrees. So what it means that is that the angle here, SPQ, so we go from S to P to Q. So SPQ, so this angle right here is 90 degrees. Angle SQR, so we go from S to Q and down to R. So we're talking about this angle here, going from S to Q and then Q to R. And so this angle it formed here between this side and this side is 82 degrees. Angle QSR, so go from Q to S to R. So this is the angle we're referring to. The angle formed by this side and this side is 30 degrees. Remember, the angle is formed when two sides meet at a point. So these two sides meet at S, and the angle formed here is 30 degrees. Okay, so now we understand how to really find the particular sides and angles. Let's look at the question. It says determine the length of PS. So we want to find the length of this side here. All right, so let me just put an X on this side so we can identify what side we're trying to find. We're trying to find the length of P to S. What is the measurement in centimeters? Okay, so let's see what we have so far. We have a 90 degrees angle, and we know this measurement here, which is 8 centimeters. How would we go about finding the length of PS? Well, in order for us to use Pythagoras theorem to find, and when I say Pythagoras theorem here, for any right angle triangle, let me just draw a right angle triangle here, sketch a right angle triangle, I should say. if we're given one side, we need to have the length of, well, let's assume that we're given this side, which is, let's say, 5 centimeters. In order for us to find this side, we need the length of this side. All right, so to use Pythagorean theorem in a right angle triangle, you need to have two sides to find the third using the Pythagoras theorem, or Pythagorean theorem. So if you look at this, what we have here, this is a right angle triangle, yes. I'm talking about triangle PQS, this triangle here. We only have one side, so we cannot use Pythagoras theorem. Now, if you were to look at this though, even if we should look at these two angles and say, hey, we can find the third because this is a triangle PSR or QRS. This triangle here has two angles, so we can find the third because this would be what? 82 plus 30 degrees, and we add those two, and the answer we subtract from 180 to find this third one because we know the three angles should add up to 180. Even if we should find this angle here, that will have no impact on the length of these two sides here. I mean, we won't be able to find these two sides, by just finding this angle here. However, can we actually identify what angles we have here? Can we identify any of these angles? Because obviously, currently we won't be able to use Pythagorean theorem to find the length of PS. So can we use trig ratios? Because it's a right angle triangle, so we can either use trig ratios or Pythagorean theorem based on what we're given. And so, okay, so if you look at this angle here, we aren't able to determine what angle this is based on this. But if we are to look at this here, this is what? This is a Z. This side is parallel to this side, correct? All right, and so one other thing you want to remember is that if you have two parallel lines cut by a transversal, then the alternate angles, in other words, this angle here and this angle here are considered to be alternate angle. They form a Z if you want to look at it like that. Right, so this angle here is equal to this angle. All right, and this angle here as well, this one here, is also equal to this one. Right, these are alternate angles. And so if you look at this, here we have the same Z. All right, so if this angle is 30 degrees, then this angle here is also 30 degrees. Because we can find the Z here. Remember, it must be involving two parallel lines. And QS will be considered to be a transversal. Just extend it like that, then we can see that this line here, SQ, is a transversal. So we have the two parallel lines, PQ and SR. So this angle here is 30 degrees. All right, so we can identify that this angle, PQS is actually 30 degrees. And it's based on the fact that we have alternate angles. So we can say angle PQS is equal to 30 degrees. And we can say alternate angle, right? Alternate angles. Okay, so we now know this is 30 degrees. And by the way, we could find this one as well too. This is actually 60 degrees. Because if you look at it, these two sides are parallel. And we have this is 90 degrees. So this will obviously be 90 degrees as well. And so if this is 90 degrees, then once given part of it, which is 30, then the other part must be what? 60 degrees. All right, so we say that these two angles, 60 and 30, are complementary angles. I mean, they add up to 90 degrees. All right, but what we can do, we're going to use just this angle here to help us to identify what side this is. So if this is the acute angle that we're looking at, we could also use a 60 for the triangle PQS. But we're just looking at, let me just draw this here so it's not too confusing. So we have a right angle here, we have 30 degrees here, we have this measurement, which is 8 centimeters, and we want to find the length here. So this side here is our opposite. It's opposite the 30 degrees, the acute angle. This side here is our what? Our hypotenuse. All right, so we have opposite and hypotenuse. So which ratio do we use? Remember, SOH CAH TOA. Which one do we use? We have the opposite and hypotenuse. Of course, sine. So that is sine of the acute angle, which is 30 degrees, is equal to the opposite, which is x, over the hypotenuse, which is 8 centimeters. And so we can cross multiply, since we have an equal sign between two fractions, 1 times x and 8 times sine 30. And so this will give us 1 times x is x, what the equal sign, 8 times sine 30 degrees. And so x is equal to, now sine of 30 is 0.5 or a half. That's a half of 8, which is 4 centimeters. Remember, 8 is really 8 centimeters. So our answer is x being 4 centimeters. In other words, the measurement for this side here, PS, is 4 centimeters. Now we could have used this angle of 60 degrees. Could have used that. All right. Let's see, how would we use that? All right, so we have the right angle triangle here, which is PQS. I would notice this angle here, PSQ right here, is 60 degrees. So therefore, this side here, in relation to the 60-degree angle, is our adjacent side, which has the right angle and the acute angle, 60 degrees. And this side here, which is facing the right angle, is our hypotenuse. And so this time we'll go with what? Which ratio should we use? Since we have the adjacent and hypotenuse, we go with this one, cosine. And so that will be just showing you basically that we can get the same length for PS if we use this acute angle of 60 instead of the 30. And so let's continue. So we said we're going to use the cosine theta equals up with adjacent, is equal to the adjacent over the hypotenuse. All right, and so cosine of the acute angle, now we're looking at 60 degrees over the adjacent, which is PS, or we could use x for PS if we want to. And the hypotenuse is 8 centimeters. And so to find PS, we can put this over 1 and we can cross multiply. So PS times 1, I mean the length from P to S. That's why I said we could actually use one letter to represent it. And 1 times PS will give us the same PS. Put about the equal sign. And this will be cosine of 60 degrees times 8. We should write the 8 in front and cosine 60 afterwards. Using a calculator, you can just write it just like this, 8 cosine 60. And this will give us 8 cosine of 60 is actually a half. Just like sine of 30 is a half, cosine of 60 is also a half. That's a half of 8, which is 4 centimeters. Using the calculator, you realize we get the same. So we got the same answer of 4 centimeters. Now let's look at the next side, the next length, which is PQ. So to find PQ, now we have the length of this side here, 4 centimeters. We have the length of this side here. So for this right angle triangle, we have two sides. We have PS and we have SQ or QS, 8 centimeters. So now we want to find the length of this side here. We have two sides, want to find the third. What would you do? I mean, we could use trig ratios since we have the acute angles. Any one of them, we could consider any one of them along with the length of one of these sides to find the third one. But we do not have to do that. Once you have two sides and want to find the third, we could use what? That's correct, the Pythagoras theorem. All right, so we have a right angle triangle, which is PQS. We have the measurements to two sides, and we sketch it over here. All right, so you can actually see what we have done there. All right, So that's the same triangle, basically PQS. And we just need two sides to find the third side. So let's consider this side to be x. PQ is equal to x. So you want to find what PQ is. Let's consider it to be x. And the theorem we're going to use is the Pythagoras theorem, which states that if you have two sides, you can find the third using this formula. C squared equals a squared plus b squared. Now c is always a hypotenuse. So we need to identify the hypotenuse which faces the right angle, which is 8 centimeters. So we're going to put 8 here. So 8 squared is equal to a. A could be this. Let's make this a. We're given a, which is 4 centimeters. So that's a is 4, so it's 4 squared plus, and b will be this side here, PQ. So that's going to be x squared. All right, so let me just explain this quickly. In the formula, C is our hypotenuse, the side that faces the right angle. So we replace C with 8. What about A and B? Obviously, the other two sides. Since we identified the hypotenuse as 8, the other two sides will be A and B. It doesn't matter which one is A or which one is B. Let me just make that clear. It doesn't matter which one is A or B, because we're adding here, right? We're adding here. And it doesn't matter the order. It could be b squared plus a squared or a squared plus b squared. So anyone could be given the measurement of 4 centimeters in terms of a or b. We just choose to let a equal 4 centimeters. We could have let b equal 4 centimeters, but it doesn't matter. You can try it and see. So that will be 4 squared plus, and b, we'll let this side that we want to find be just one letter, and we use x. All right, now that you understand that, we can move on. And so this is going to be 64 minus, well, we're going to transpose this 4 squared over. So let me just take it one step at a time then. All right, so it's 64. 8 squared is 64 equals 16 plus x squared. Transposing the 16 over, we have 64 minus 16 is equal to x squared. And 64 minus 16 is actually equal to 48, which is equal to x squared. So we have x squared is equal to 48. Now we want to transpose the square over. Once we transpose square, it becomes square root on the other side. So we find the square root of 48. And that will be, let's find the square root of 48. And that will be approximately 6.928, etc. Now, let's assume that they ask us to round to 3 significant figures. 6 is the first, 9 is the second, and 2 is the third significant figure. So when we check the next digit, it's 5 or more. So we're going to add a 1 to the 2. Once the next digit that you check is 5 or more, we're going to add 1 to the required significant figure. So significant figure here we're looking at is the third, which is a 2. So we're going to add 1 to the 2. And so our answer will be equal to 6.93 centimeters, corrected to 3 significant figures. All right, so now we need to look at angle PQS. Now, where's angle PQS? So we're looking at here, P, going to Q, going to S. And we actually found that angle. That angle is actually 30 degrees.